Nyctophobia is the fear of the dark. But there's another fear that's more chilling. It's the fear that darkness will go away. Optophobia, the fear of opening your eyes. The speed of dark is the speed of light, but there are other types of darkness that can move faster than light speed. Consider a shadow. Across a distance, a shadow can become much larger than the object creating it, but still mimic its source, moving in the same way for the same amount of time. So when a shadow is bigger than the object casting it, it moves a greater distance. When the object moves, but in the same amount of time, make a shadow large enough, and it can travel across the surface faster than light. If you, here on Earth, cast a shadow onto the moon, not an easy thing to do, that pointed from, say, point A on the moon's surface, and then you moved your finger so that the shadow moved to point B, your finger would only move a few centimeters in a fraction of a second. But the shadow it cast on the moon would move thousands of kilometers in the same amount of time. Do it right, and you're easily producing a shadow that breaks the light barrier. But nothing's wrong here. The rule is that information can't travel faster than light. You can't cause something to happen somewhere else faster than light could travel from you to that somewhere else. And our superluminal shadow is transferring no information from point A to point B. Sure, point B is being cast into darkness sooner than a light speed message from A could warn him it's coming. But darkness isn't traveling from point A to point B. It's traveling from you to point A and point B at the speed of light. What we tend to call a shadow is really just a cross-section of a three-dimensional region. The darkness you are causing only changes shape when newly unblocked light fills the previous gap. That's all shadow is, a gap. The region where an object completely blocks a light source is called the umbra. It's the darkest part of the shadow in the most prototypical part of the shadow. Where only a portion of the light source is blocked, we find the fainter penumbra. But as two or more penumbras approach and overlap, the combined amount of light they block can be enough to produce a perceivable difference, the shadow blister. The Earth has a big umbra. It's 1.4 million kilometers long. That's how far away you'd have to be from the Earth for it to no longer have a large enough apparent diameter to block out all of the sun. Here, on the surface of Earth, we are nowhere near that far away, which is why night is so umbral. Night is just the Earth's shadow falling on you. If the sun is less than 6 degrees below the horizon, it's technically civil twilight. You can still do plenty of stuff outdoors without the need for artificial lights. Down to 12 degrees below the horizon, we have nautical twilight. Artificial lights are more or less necessary, but the sky still scatters enough light to be bright enough for ships at sea to navigate by seeing a contrast of the horizon between dark sea and faintly lit sky. Down to 18 degrees, an astronomical twilight is occurring. It looks like night, but the sky can still get darker. Until astronomical twilight ends, not all nighttime astronomical observations can be made. Below 18 degrees is technically, honestly, night. If you live at greater than 48.5 degrees north or south latitude. When scissor blades snip, the intersection point between both blades moves faster than the blades themselves. Think of it this way. If you had a pair of scissors with blades that were a light year long and it took 1 second to close them, the intersection point would have traveled an entire light year. In not a year, But a second. No laws are being broken here because such a snip would be physically impossible. As I've mentioned before, rigid objects don't move instantaneously all over when a push force is applied to them. Instead, that force moves via electromagnetic forces from one atom to the next, and so on down the line. A compression wave. When waves collide, their crests can fuse into larger crests, their troughs into larger troughs. This is constructive interference, but crests colliding with troughs cancel out. Destructive interference. If these waves are light, the result is darkness. And, in certain circumstances, darkness created this way can travel like the intersection between two lines, faster than light. Imagine these concentric circles as waves of light. The lines are wave crests, and the gaps in between are troughs. When they meet the points where they intersect, flee up and down faster than the waves travel, especially in the middle, which, in the case of light waves, makes them faster than light. The superluminal speeds of these dark patches can be seen really clearly if we make the wave crests of one source black as well as the background. Overlapping regions where red peeks through represent destructive interference, darkness. Wheeler is an extreme example and was the inspiration for the Dunning-Kruger effect. Novices, people unskilled in particular disciplines, will often overestimate their knowledge and abilities in said disciplines because they don't even know how little they know, how much more there is to learn. On the flip side, experts in a particular field will often underestimate their knowledge, have less confidence in their abilities, or think that everyone else has the same level of knowledge that they do. Imagine using geometry to illustrate how ignorance grows faster than knowledge. As our circle of knowledge expands, so does the circumference of darkness surrounding it. Learning, studying, shedding light on a field of inquiry also reveals just how in the dark we continue to be. How many shadowy things there are left for us to illuminate. The diameter of light never exceeds the shadowy circumference. But what's the speed of that kind of dark? The speed of the growth of the number of things we know we are in the dark about. What's the speed of ignorance? If we define ignorance as the difference between questions we know to ask and answers we have, the field of agnotology, the study of ignorance, suggests that the amount of things we know we are in the dark about is growing faster than the amount of things we have shed light on. Is it a coincidence that the phrase "in the dark" originated during, of all ages, the Age of Enlightenment, when Leeuwenhoek put a scraping? What's really cool about the expanding size of our nescient circumference is what Stuart Firestein, the chair of biological sciences at Columbia University, has said about it. It is there that science begins, where the facts run out, just beyond them. He says, it is a mistake to bob around in the circle of facts, instead of riding the wave to the great expanse lying outside the circle. If science is a road trip, facts are the photos we take along the way. The fuel that drives it forward is ignorance. Facts. More like facts. Part of the past, not the way forward, when it comes to understanding our world. And as always, thanks for watching.